All right, today we're going to look at the relationship between graphs that you already know and square root graphs or radical graphs or graphs that are super cool. So let's take a look at this line that we have drawn up here, which is the line y equals 2x minus 2. What do you already know about that line? Well, there's two things. Number one, you know that that number is called your slope. And the slope is saying here, if you look where my cursor is, up to over 1. Up to over 1, that's our slope. Minus 2 is our y-intercept, our b value. And it crosses, this graph crosses the y-axis at minus 2. But it's also a transformation of the graph y equals x. If you think about what this minus 2 means, it means it's the original graph, y equals x, but it's been moved down 2. And what this multiplier of 2 is simply saying that there's been a stretch. And so we can look at it both ways. Now, what we're going to look at now, though, is the graph of the square root of that same function. So we're going to take some points now, and we're going to plot them onto this graph, and we're going to see how the new graph looks. So let's first start off with putting in 0. If we put 0 in for x, we get an impossible answer because we will get the square root of minus 2. I can't do that. So we got to start somewhere where we get 0. So what answer we'll get is 0? Well, if x is 1, we're going to get the square root of 0, which is 0. So that's where this graph is going to start, because it can't square root a negative number. There's no minus sign in front of there. You can't square root a negative number at all, except for when we talk about imaginary numbers, but we're not there yet. Let's put in the next value. Let's put in 2. 2 times 2 is 4. 4 minus 2 is 2. The square root of 2 is bigger than 1, but not a heck of a lot. What if we put 4 in? Well, 2 times 4 is 8. 8 minus 2 is 6. The square root of 6, anybody? 2 point something. So it's going to be there. What if I put 6 in? 12 minus 2 is 10. Square root of 10 is 3 point something. And you can see our graphs is going to continue on. Let's go ahead and put 10 in. 2 times 10 is 20. Square root of 18, 4 point something. And we can see that there's a relationship there. And so the key thing that we're going to look at is simply answering these questions. Number one, how are the graphs related? Number two, where are their invariant points? And how is the domain and range affected? And the big question is, could we use this graph, which we already know how to do, this purple line, we already know how to graph lines, to graph our root function by seeing some tendencies. And that's all we're going to do. And so when you come to class next time or when we get together, we're going to look at some specific examples and see how that applies, how we can use what we already know to find out something new. And that is it.